Greetings, fellow human, and astronomical welcome to our channel. Have you ever just wondered what particles are such which can't be broken down further? Or what are the building blocks of the universe? Or how do two objects know if there is a force operating between them? Well, surprisingly, all these questions somehow have a similar answer. Well then, tag along as we begin this joyride down to the depths of quantum realm and bring you these mind-bending answers. The standard model of physics is, in Hawking's words, an early attempt of a unified theory of everything. This standard model successfully describes three of the four fundamental forces of the universe with the exception of gravity. It classifies the building blocks of the universe into the so-called elementary particles into various groups, which we will soon see. When the universe popped into existence with the Big Bang explosion, there was a superforce, the parent of all the four fundamental forces in our universe today, called the Great Unified Force. In a billionth of a second after the Big Bang, this superforce split into the four fundamental forces: gravity, strong nuclear, weak nuclear, and electromagnetic force. And all these forces came into being. As soon as the split of the forces happened, the laws of nature came into being. This literally means that before this point in time, there was no law of nature or law of physics, or whatever was, it was completely different from the one we have today. The standard model classifies all the elementary particles into two major groups: fermions, the matter particles, and bosons, the force carriers. Fermions are further divided into quarks and leptons, as you can see, and bosons are divided into gluons, photons, WZ boson, and finally Higgs boson. The quarks can't exist freely, so they combine to form various particles, like hadrons, for example. Examples of hadrons are like neutrons, protons, etc. Then comes the bosons. These bosons are literal force carriers. Electromagnetic force allows allows particles to interact with each other via electric and magnetic field. The standard model explains the same phenomena via the use of force carriers called bosons. You see two objects A and object B. How do they know that if electromagnetic force or gravity or some other force is acting between them? This purpose is fulfilled by what is called a boson. As mentioned earlier, all the four fundamental forces have their own carriers or bosons. The electromagnetic force is carried by photons. Yes, the light particle. It indeed is the carrier for electromagnetic force. Then comes gluon, which carries the strong nuclear force, the force operating inside a nucleus, the one that keeps the protons and neutrons binded in a nucleus. Then comes the weak nuclear force, which is carried by the WZ boson. And then comes Higgs boson. Although Higgs boson is not associated to a force, but those who have been following our channel for long know how awesome this particle is. In brief, Higgs boson basically provides mass to particles. And the other name for Higgs boson is literally God particle. Gravity, on the other hand, does not have a force carrier because, as explained earlier, standard model does not include gravity because the force carrier for gravity, the graviton, which is a theoretical particle existing in the standard model, but it does not define it, or there is no proof that graviton exists or that even gravity is a force according to Einstein. There are other particles as well in the standard model, like the neutrinos, which deserves its own another video. The Standard Model is our first attempt at a unified theory of everything, the so-called Holy Grail of physics. It's important to note that while this theory, the Standard Model, can predict many things, but it certainly isn't without its flaws. So, the Standard Model, for example, does not explain dark energy and dark matter. Scientists have recognized this problem and they are working towards finding newer forces and newer particles so that finally we can explain everything via one theory. That's it for today, folks. If you like this video, then please do consider subscribing to our channel. Until next time, I'll be your friendly neighborhood, the Astrophile.